This is the third lesson of Unit 6 on compound interest. So we talked briefly about compound interest in the last lesson, so we're just going to start with a bit of a review here. So simple interest is interest paid on only the principal of an investment or loan. And remember, the principal is just the initial amount. Okay, and simple interest has a linear growth. Again, that just means it's increasing by the same amount each time. On the other hand, we learned that compound interest is interest paid on, again, that principal as well as its accumulated interest. Okay, so that, again, was the main difference there, is that you involve the interest in the new principal, basically, or the new total amount. Calculated at regular compounding periods and added the principal for the next compounding period. Okay, and this type of interest compound has exponential growth. So the longer that something is being compounded, the more money you will get and the faster it will grow. Okay, but again, we learned that works the other way as well. If you're borrowing money, the longer you have it borrowed for compounding, the more money you're going to end up owing. So in the last lesson, what we did is we filled in a table using simple interest to calculate compound interest. In this lesson, we are going to learn that just like simple interest, there is an equation for compound interest. So the formula that we'll be using is A equals P times 1 plus I to the power of n, where A is your total amount or your future value, P is your principal, which is your initial amount, I is your interest per compounding period. So it's not going to be your total interest. We're actually going to have to do a bit of work in order to calculate that I value, as well as the n value, which is, it's not necessarily the number of years. Instead, it's the number of compounding periods. So just looking at some terminology here first, which we saw a little bit in that first note. Compounding frequency terminology. So if something is compounded annually, remember I told you that annually just means per year. So that means you're being compounded just once a year. Semi-annually then, semi means 2. So that means you're being compounded 2 times per year or every 6 months. Quarterly, we know that quarter means 4. So that means your money is getting compounded 4 times a year. So that means at 4 different points, it is going to add on that interest, and you're going to start making interest on that new amount. That's what that means. So the only thing we've looked at so far is annually, which just means that it's only being compounded or added together every year. So it can be added together a lot more often than just once a year. Semi-monthly, that's 2 times a month. We have 12 months, so that's 24 times per year. Bi-weekly means every other week. We know that there's 52 weeks in a year, so bi-weekly is 26 times. And lastly, weekly, like I said, there are 52 weeks in a year, which means it would be compounded 52 times. Okay? Not necessarily 4 times a month, but 52 times over the entire year. Okay, so using that information, we need to figure out our interest rate. So it says calculate the interest rate I as it would appear in the compounding or the compound interest formula. Hint, convert to decimal and divide by the number of compounding periods. So this is very, very important. This is what we're going to have to do every single time. Convert to a decimal, step 1, and then divide by the number of compounding periods. So, converting to a decimal is just, remember, dividing by 100 or moving that decimal place 2 spots to the left. So if I do that, I get 0.06. And I need to divide by how many compounding periods. And where do I get that? Well, it tells me in the question, right? So semi-annually, I scroll back up here. That means it's 2 times per year, so I'm going to divide by 2. That means that my interest rate is 0.03 per compounding period. Okay, so the next one is 5% weekly, so I'm going to start by converting to a decimal. Weekly, look up here, that's 52. So I'm dividing by 52. I get 0.001. That is the amount of interest I am making per week. Okay, and lastly, 1.75% quarterly. So convert to a decimal first. So move that decimal point 2 places to the left. And then divide by the amount of periods, compounding periods. So quarterly means there's 4 periods, so we're dividing by 4. That means our interest rate for each of these periods, each of these compounding periods is 0.04. Okay, awesome. If you're like, okay, that's easy, I just have to remember to convert it and then divide, right? You had to convert it before, the only difference is now dividing, but try to understand why. What this means is this percent for each of the periods that it's compounding. Okay, so we have to calculate I in a bit different way than we did before. We also need to calculate N, which is our compounding periods. So it says, calculate the number of compounding periods N as it would appear in the compound interest formula. Hint, multiply the length of time in years by the number of compounding periods in the compounding frequency. So that's wordy, but it's not as hard as it seems, okay? So all we have to do is multiply the length of time in years. So this one tells us 5 years, so we need to multiply 5 by the number of compounding periods. So in my question here, I see the word quarterly. So that means there's 4 compounding periods, which means my N value is 20. Okay? The next one, we see it's semi-annually for 18 months. So we have to still, just like we did before, we need to make sure that we're in terms of years. So we have to first figure out how many years is 18 months. So you should remember to do that, we divide by 12. That's from the very first note. So 18 months is 1.5 years. Okay, so now that we know that, we have to multiply it by the number of compounding periods. Semi-annually means twice a year, so we're going to multiply by 2. That means that 3 is my N value. Okay, lastly, again, we're given, this time it's bi-weekly for 8 months. So again, we need to make sure we don't just multiply by 8 right off the bat. We need to make sure it's in years. So 8 over 12, which as a decimal is 0.67. And then bi-weekly means every other week. There's 26 weeks in a year. So 17.33 is our N value. Okay, so very simple calculations. Just multiplying and dividing using your calculator, but you need to make sure that you actually do this or your numbers are going to be off, right? We can't just simply sub in the amount of months. We need to sub in the specific amount of compounding periods because our percent that we are putting into our formula is for each compounding period, not for the total amount of years. Okay, so I'm hoping that this will make a bit more sense with some examples here. So our first example says, calculate the amount of a $500 investment invested at 3% compounded quarterly for 3 years. So again, I want you to get into the habit. You should have been doing this for all word problems, but with these, it's especially important to highlight or underline the important information. So we know they're investing $500, and it's at 3% compounded quarterly for 3 years. Okay, and it's asking us to calculate the amount. So again, you might just want to write your formula up top so you have it right in front of you. So this is just from the front page. 1 plus I to the power of n. So just like before, what we're going to do is we are going to write out all of the parts. So P, I, and N are 3 pieces of information that we need to calculate total amount. We know P is principal, same as before. So according to our question, that's 500. Okay, I and N, we have to do a bit more work, right? So I, remember, is the interest rate per compounding period. So I have to first convert to a decimal, and then I have to divide by the amount of periods. So because it's quarterly, I'm going to divide by 4. That means my interest rate per compounding period is 0.0075. You're going to want to take quite a few decimal places here, right? If not, we would have just rounded this to 0, and that's not going to help us. We need a couple decimal places there for sure. Okay, and then to find the n, which is, remember, the number of compounding periods, we take our years and we multiply by how many compounding periods there are per year. So you should be multiplying by the same number that you divide by. See how those are both 4? That's always going to be the case. You're always going to be multiplying by the same number you divide by. And 4 times 3 or 3 times 4 is 12. Once we have all of that information, it's just a matter of substitution. So the total amount equals the principal, which is 500. 1 is always part of your equation, plus your I value to the power of your n, which is 12. So it's going to be important here to make sure that you are using BEDMAS correctly, right? So you're not going to be able to type all of this in one step. 1 plus 0.0075 is 1.0075. Okay, so we did the addition with brackets, right? So brackets, now we would do exponents. So we would do 1.0075 to the power of 12 equals times 500 gives you $546.90. So that's how much money we would have after 3 years in this investment. So we didn't invest a lot of money, right? We only invested $500, which may be kind of realistic for you guys, right? Because you guys are obviously not going to have a lot of money. But even if you invest just a small amount, $500, the rate here is pretty low, probably pretty realistic. For 3 years, you would end up having $546.90 at the end of it. So how much interest was earned? So to figure out the interest, we need to take our total amount and subtract our principal. So that's just a rearrangement, basically, of our, what was our amount equals P plus I, right? So that's just that formula kind of rearranged to have the I isolated. So when I do that, I have interest equals 546.90 minus 500 leaves me with $46.90 of interest. So you made almost 50 bucks on interest in this investment. Okay, example 2 says Peter borrowed $5,000 to buy a used car. Shouldn't be a question mark there. The interest rate on the loan was 5.45% per year, compounded monthly. He plans to repay the loan in 4 years. So part A says, how much must Peter repay? So same as before, we're going to highlight the information. So, whoops, it's not my highlighter. So we borrowed $5,000, okay? here's our interest rate per year, which I don't even need to do the per year. So that's my interest rate, compounded monthly, and we're repaying in 4 years. Okay, so again, it's always going to be helpful to write out your variables and fill in the information you know. PINN. So P is how much we borrowed, the principal, the starting amount, $5,000. Our interest rate as a decimal is 0.0545 divided by however many compounding periods there are per year, which is monthly, so we have to divide by 12. So that's 0.005, and n is the number of years times the amount of compounding periods per year, which again is 12 because it's monthly. So there are 48 compounding periods. So this might not be too good for Peter here, right? Remember, it's always better if you are borrowing money to have simple interest, right? Because you know it's just going to go up by the exact same amount every single year. Whereas with compound interest, eventually, depending on how long you wait to repay your money, you're going to end up paying a lot more than you initially took. Okay, so now is just a matter of substitution, right? So A equals 5,000, 1 plus 0.005 to the power of 48. Again, make sure you're using BEDMAS. So brackets first, add those together. Then your exponent, 1.005 to the power of 48. It's easiest not to write out this step just because you want to include a lot of decimal numbers. Or if you do write it out, just leave it on your calculator and then click times 5,000, which gives you an answer of $6,258.10. Okay, so that is the amount that Peter would owe if he borrowed $5,000 at this rate and he paid it back after 4 years. Okay, so the next part B, says if Peter repays the loan 6 months early, how much interest will he save? Okay, he's not technically saving the interest, but he won't have to repay it. Okay, so same as before, P, I, and N. Our principal remains the same, right? He's still going to take out the same amount of money. He's just going to repay it back earlier. Okay, our interest rate is still going to stay the same. Our N value is going to change, right? So instead of 4 years to pay it back, he's actually going to pay it back after 3.5 years. Again, we have to multiply that by the amount of compounding periods per year, which gives us 42. Okay, and then same thing, right? We're just going to use substitution. I'm just going to skip a step here, and you're welcome to do that too. 1.005 to the power of 42 times 5,000 is 6,165.16. So that amount obviously is slightly different than the one above, right? So we need to refer back to the question. It's asking us how much will we save if we repay it early, right? So what we have to do to figure that out is take the original amount, subtract the amount if he does it early, and obviously you guys would just use a calculator here. I'm just setting it up. Oops. Okay, and then you can just use your calculator, which is going to tell you that the difference is $92.94. So as a concluding statement, he would save $92.94. Okay, if he repaid the loan 6 months earlier. Okay, last example here, and then just some quick rules of thumb. Jennifer's investment has grown by an average of 12.6% per year compounded annually over the past 7 years. How much would her investment of $2,000 made 8 years ago be worth today? So the wording on this one is a bit confusing, but try to just simplify it. It's just saying she had an investment, she ended up making $2,000 on it 8 years ago. So if that $2,000 continued to make interest, how much is it going to be worth today? So it's the exact same procedure. Okay, and it's been 8 years since we made that $2,000. So same procedure in the sense that you're going to start with P, I, and N. Principal here is 2,000. Our interest rate is 0.126, so a lot higher than usual. And that's compounded annually, so really we would just divide it by 1, which just means it's going to stay the same. Okay, and our N value, we're looking that she made $2,000 8 years ago, so assuming she kept that money in this account, how much is it going to be worth today? So again, all we would do is multiply that by 1 because it's only going to be compounded 1 time each year. Once we have that, sorry, I'm just going to fix this. Once we have that information, it's just a matter of substitution. 2,000. And you'll notice that I'm just adding those together. This is an 8, not a 0. Adding those together in that first step. 1.126 to the power of 8 equals times 2,000 is $5,168.17. So again, always good to get in the habit of those concluding sentences. The $2,000 would, how do I want to word this? Would become this amount with interest after 8 years. Perfect. Okay. And we're almost done. Just some general rules that you want to keep in mind when you're calculating compound interest. Always identify the value of each variable first, which is what we've been doing kind of on the left-hand side each time. So writing out all of the variables and filling in the information you know. Remember to always use BEDMAS, so you want to make sure that you are starting with that bracket, then doing the exponent, and then finishing off with your multiplication. Keep all decimal places in your calculator and round to 2 decimal places at the end. So that's kind of what I was saying. Do your 1.126 to the power of 8 equals, leave it on your screen, and then click times 2,000. So you have all of those decimal points so you can make sure your answer is as accurate as possible. Obviously, in all of these questions, we've been dealing with money. So just make sure you're always rounding to 2 decimal points because we know even though we don't have pennies anymore, we still use 2 decimal places when we're dealing with money. Okay, so this is the end of the 3rd lesson in our 6th unit on compound interest.